mathematical music. Table of contents. 1. Introduction. 2. Calculation. 3. Analyze. 4. Constructing. 5. Interviewing. 6. Communicating. 7. Extending the project. Introduction. We are research today attempting to explore musical instrument through the application of math. We are employed by a scientific research group that look into intriguing phenomena and connection among various facts of our life. So today, we consider how math explains music. To begin, we will look into the variety of musical pitches. Next, we will play several basic instruments and compare the ratios of string length to pitch. Lastly, we will pick one musical instrument and use mathematics to explain how it creates various pitches.
Calculation. So the formula we need to use to calculate the string length is y equals k divided by x, which would happen to be 523 times 420 equals 219,660. So we will use that number divided by the pitch, which would equal to the string length. And down here are the pitches, frequency, and string lengths. Analyzing. By simplifying ratio by dividing each number with 14, you'll end up with 30, 24, 20, and 15. And the ratio would be 30, 24, 20, and 15. Once simplifying the ratio of the string lengths by dividing each number with 14, you would end up with a ratio very similar to the one given with, or compared with. All numbers were the same between the ratios of the string length and the ratio given to compare with, while only having one difference. The only difference is the second number, 23.7 or 24 when rounded up. When this particular number is rounded, the two ratios are completely the same, but when it isn't, it's fairly close to one another. Constructing. This is our product. As you can see, the longest tube, C1, is 18 cm, second longest tube, E, 14.4 cm, third longest tube, G, 12 cm, and fourth and shortest tube, C2, 9 cm. This is our video. You can click on it in our slide. 5. Interviewing. Now, these are the video interviews. We won't show it in this video, but you can go to our slide and click on it to see the video for yourself. So a guitar has 6 strings, E, A, D, G, B, and E, which are the pitches. To play a guitar, we need to tune the guitar using the lower strings to up. To get an idea of how each strings could be played, we have to tune the thickest string of the instrument to first, we gotta play the string and listen to its sound. If the sound is too low or deep, you can try tightening the tuning peg by turning it in the opposite direction. If the sound is too high or sharp, you can loosen the turning peg a bit by turning it to the opposite direction instead. The goal for this is to adjust the turning peg until the starting sound of the string machine matches the pitch that you're looking for. And third, once every string has been tuned, repeat the steps to make sure that every string is tuned, because changing one string can have a significant effect on others. And fourth and last step, you have to, after making the changes, don't forget to softly pluck the strings and allow them some time to settle, because if not, your guitar will break so easily, trust me. Now here are our posters. The first poster represents the parts of the violin, consisting of scrolls, peg boxes, pegs, fingerboards, tabletop, strings, purfing, sound hole, and tailpieces, which are considered to be the main parts of the violin. The second poster represents how the violins work. First, the sound of the violin originates from the vibration of the strings. When the bow is drawn across the strings, they are plucked and they start to vibrate, creating sound waves. These vibrations will travel through a small bridge, a small wooden piece that supports the strings, and it makes the body act as a resonance chamber, amplifying the shaping and the sound produced by the strings. The soundboards vibrate sympathetically with the strings, effectively amplifying and projecting the sound outward. The combination of strings, vibrations, resonance with the body, and the soundboard's application makes it so that the violin could work together in harmony and produce beautiful sounds. And this is our last poster. As you can see, it's made on paper and it's designed with a picture of a flute and a picture of a human playing the flute. It explains what the flute is used for and how it is used.
Extending the project. In Western culture, see and C sharp are conductive pitches in the chromatic scale. The ratio of the frequencies is about 1:1 to 1.06. Type of music. Western music. 10-note pentatonic scales such as C, D, E, F, G, A, and B are frequently used in Western music. It gives the form of the rearrangement and the harmonies connection a lot of weight. It's also divided up into separate sections. The size of the Western Symphony Orchestra might change based on particular piece of music that is being played. Eastern music. Eastern music uses microtones, which are intervals smaller than the semitones or semitones found in Western music. These microtones allow for a greater variety of tonal nuances and subtle variations in pitch. Musicians are often encouraged to add embellishments, trills, slides, and bends to their performances, allowing for individual expression and interpretation.
Conclusion: we explore music instrument by making flow modern to understand and affect the sound. We test with our teammates, record the process. Then we learn about violin impact and talk to checking about turning. This project show us how math, music are connect and how radio and measurement crucial for making a great music.
Thank you for tuning into our presentation, and I hope you all have a great day.